All right, let's continue with our study on circles. Today we are going to study angles that are partially inside the circle and partially outside the circle. Here's our first theorem. It's the chord tangent theorem. It says if a tangent, this line, intersects a chord, so that's the chord, at a point on the circle, so this point right here that's right on the circle, then the measure of each angle formed is 1/2 the measure of the intercepted arc. So what that means is the angle that's in here is half the arc out here. And then same thing on the other side. The angle in here is half the arc that's on the outside. All right? Okay, so now we have to know the difference between these three types of angles. Here we have an inscribed angle. Here we have a central angle. And then here's the new one that we've been learning with the chord and the tangent line. So the first one we learned was this one. The theorem said whatever the central angle is, the arc is exactly the same. So this is 35 degrees. Yesterday we had this one, which is called an inscribed angle. And its theorem said that whatever the inscribed angle was, you have to double it to get the arc. Okay, so know the difference between central angle and inscribed angle. And then today we are going to do the chord tangent angle. And the theorem that we just saw was that whatever this angle is, you have to double it to get this arc. So this is 70. All right, so these two have the same rule. Okay, we can do a tricky example. We have to find x, which is right here. There's two ways to do it. We'll do it both ways. Okay, notice that this arc from here all the way around is 200. So the rest of the circle must be 160, because as you know, a whole circle has 360 degrees. All right, so if this part of the arc is 160, according to our theorem, if we take half of it, we should get that angle on the inside, 80 degrees. Okay, that's one way to do it. Let's do another way. Start off the same. We know the arc is 200 degrees, which means that this angle in here is 100 degrees. It's half of the arc. And then these two together from the very first week of school, these two are a linear pair, which means they have to add up to 180. They make a straight line. So x is still 80. All right, both ways will give you the right answer. Let's throw a little bit of algebra into this. Here we have an angle, and then the arc is 3x minus 5. To set up the algebra problem, all you have to do is double that angle, and it should give you the outside. Use a little bit of algebra. 2 times 55 is 110. Let's go ahead and add 5 to both sides, and then divide it by 3. Pretty simple. Time for another theorem. We have the two chords theorem, and it says if you have two chords intersecting in the interior of a circle, so two chords that cross each other inside the circle, not necessarily at the center, but they just cross somewhere. Then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. All right, so here's what that means. We have an angle right here. The theorem says if you take this arc and then this arc and then you add them together and divide it by 2, you get that angle. Here it is, and mathematically, the measure of angle 1 is equal to 1/2 the measurement of arc BC plus the measurement of arc AD. All right, let's go ahead and do an example. This one says solve for x and y. We'll do x first. Here's x. According to the theorem, you have to take this arc, add it to this arc, and divide it by 2. All right, so 147 plus the 45 divided by 2. So that gives you 96. Pretty easy. To solve for y, notice that the x and the y are a linear pair. They should add up to 180. So therefore y must be 184. Here's the last example for today. We're going to go backwards a little bit. They give you that angle on the inside. You have to go backwards and find the outside part. It's always a good idea to start off with a formula when you're going backwards and then just fill in whatever you know from the formula. We know that the measure on the inside is 22. And then we're looking for one of the arcs, and we're given one of the arcs. Okay, so we just plug it in, and then you just solve this equation. There's a few ways to solve it. You can distribute that 1/2 in, or you can get rid of that 1/2 right away by multiplying both sides by 2. So if you multiply both sides by 2, the 1/2 does go away, and then you just have one easy step left. Subtract 35 from both sides, and we have 9. That is the arc on the outside. All right, that's all we have for today. Thank you.